So, students, let us continue our matrix video. In the previous video, what thing that we learned about? It was about what are matrices and what is the row matrix, what is the column matrix, what is the square matrix, what is the rectangular matrix, and we also learned that why matrices are the way they are and what are orders of a matrix, all that stuff. Today, we'll dive deeper into the classifications of matrix. Classifications of matrices. Okay. So in the previous video, we learned about a few classifications of matrix like square matrix, rectangular matrix, row matrix, column matrix, and today we're going to dive a bit deeper into it. The first type of matrix in today's video that we're going to be learning about is let's do it diagonal matrix. Diagonal matrix. What is a diagonal matrix? In order to find out or in order to learn what is a diagonal matrix, we have to find out like which are the kinds of matrices that we can find the diagonals of. Okay, so like we know what diagonals are, right? Let's say we have a quadrilateral here. If we connect two opposing dots of any quadrilateral, then the line that connects these 2 points is known as the quadrilateral. It's known as the diagonal of the quadrilateral. And a quadrilateral has two diagonals. We all know that. Now this is a quadrilateral with two diagonals. We can draw diagonals of any quadrilateral, be it a square like this one, or a rectangle like this one. You can connect these 2 points, or maybe a rhombus like this one. I think it's called kite. Like this one, or even a trapezium like this one. Why you can do that? Because you know that each individual point in this quadrilaterals have their own distinct identity. But in matrices, what happens is that the elements in a matrix, they work as individual points, and you can only connect those numbers or those elements with each other. You cannot, say that these 2 points which are not elements of matrix and connect that and form a shape or form the diagonal of the matrix. You cannot say that. Like for example, I have a square matrix here. A, B, C, D, E, F, G, H, I. It's I to I with small letters as well. I. You can connect. You can draw a diagonal there. You can clearly see that. So you can connect A with E with I, and you can form a diagonal like that. But if we had a rectangular matrix, then the situation would be a bit different. Like let's say I have a rectangular matrix here. A, B, C, D, E, F, G, H. Now you can say that I can form a diagonal here too by connecting A and H. This would have made sense if this was just a regular rectangle, but since it's not that, it's a matrix. This wouldn't make any sense. No, this is not how things are. This would make sense, but this won't. Why? Because that matrix you can only connect to elements of the matrix, and you cannot, uh, have free space, empty space between the two elements, um, which can be filled by other elements. Like you cannot have that. We can, we cannot connect these two elements and say that, yeah, this is a diagonal. If you had connected A and F, then that would not have been problematic. If you had connected C with H, that would have been problematic. But you just cannot do this. Are you getting what I'm trying to say here? Because like in these 2 points, let's say that you draw a line between A and H, you connecting A and H. But in the middle of this line, places for other elements can be. Like here, if this element is this part of the line is between B and F. This part of the line is between that C and G. So this is why this wouldn't make sense, but this would, because here in this particular position you don't have an element in this matrix. So the same is here. In this particular place you don't have any element of the matrix. So you can easily connect A with E and then E with I, and this whole thing, all of these numbers A and I, all these three elements would be connected to each other. This is what is known as the diagonal of a matrix. Now you can say that I can draw another diagonal here like that. Yes, that would definitely make sense. Like there is nothing wrong with that. But here's an unspoken rule about matrix that the only diagonal that we take into consideration when we're discussing about diagonals of matrix is this one, from top left to bottom right. We most of the times ignore this one, which goes from top right to bottom left. Okay, got it. What is the diagonals of matrix? Now, what is a diagonal matrix? What is a diagonal matrix? A diagonal matrix is a matrix in which the diagonal of the matrix, that one is the only one that has elements other than zero. Every element other than every element who are not part of the diagonal would be zero. Like here we have, let's say, a matrix here, A, B, C. This is square matrix. 0, 0, 0, 0, 0, 0. As you can see, in this diagonal only, this one is known as the primary diagonal. In this diagonal only, we can find elements that are not zeros, and everyone else is zero. I mean, when you are discussing about diagonal matrix, you don't have to care about like what is going on here. So you can have zeros here as well, but that just won't matter. The only thing that matters is that if the elements outside of this primary diagonal, if those are zeros, if they are zeros, like in this case they are, you can call this what, a diagonal matrix. Okay, now let's talk about another type. It's gonna be zero or null. Zero or null matrix. Now, what is a zero matrix or a null matrix? As the name suggests, a zero matrix or a null matrix would be a matrix in which every element is zero. Like here we have a matrix of 3 by 3 order, in which every single element is zero. This one would be called a zero matrix. Now, from the previous example, the type of the diagonal matrix, like can you guys find out if this is a diagonal matrix? Can you guys find that out? Of course it is, of course, because we don't have to care about what is going on in this particular diagonal. If every element outside of this diagonal, if those elements are zero, then this would be a diagonal matrix. So this means a square zero matrix is also a diagonal matrix. Let's say we had a zero matrix, but this one was rectangular. Like, could we have called it a diagonal matrix this way? No, because diagonal matrices can only be discussed about when the matrix is a square matrix. Only a square matrix can be a diagonal matrix. But since this one is a rectangular matrix, this cannot be a diagonal matrix. Got that? Okay. Now, now we will talk about what? We will talk about scalar matrix. We will talk about scalar matrix. Scalar matrix. What is a scalar matrix? A scalar matrix is a square matrix. Again, we're only we're talking about square matrix. Square matrix are like really important. Square matrices are really important. A scalar matrix is a square matrix in which elements of the primary diagonal are the same. Got that? A scalar matrix is a matrix where the elements of the primary diagonal are the same, and everything else except that, except like every element who are not a part of this primary diagonal are zero. Every element is zero. Then elements in this diagonal, the primary diagonal. Okay. Now the next one we will be learning about is identity matrix. Now, what is the identity matrix? A matrix, a matrix in which every element of the primary diagonal is one. Is one. Everything else, every element outside of the primary matrix is zero. Okay. This means identity matrix can also be a scalar matrix. An identity matrix and a scalar matrix both can be diagonal matrix. That means identity matrix and scalar matrix both are sub branches of the diagonal matrix, which itself is a branch of square matrix. A square matrix is a branch of a matrix. Okay. Done with that. Let's see if I'm missing one. Transpose matrix. Transpose matrix, okay? Let's say we have a matrix here called A, in which elements are A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is 3. Now, transpose matrix with respect to this matrix of A, transpose matrix of A, let me write it on display actually. Matrix of A This is also written as a to the t or a to the small t or a to the capital T, both work, or a dash. Okay. Now what I'm going to do here is we are just going to flip the elements. Like the first position, like if you flip it, it's just going to remain the same. But what we're going to basically do is that we're gonna interchange the rows and the columns. Like the rows are gonna go in place of where columns used to be, and columns would go where rows used to be. And since first element is part of the both first row and first column, this is gonna stay exactly the exactly where it was. And in second place, instead of element A12, we would have this time rows would take place. Like here you can see that rows are going this way, but in this one, rows this particular group of elements would be written as this A21, A31. Same with this column A12. This column would be taken and from its vertical shape it would be flipped down, flipped up actually, and would be transformed into a horizontal in the group of distance. A12 followed by A22 followed by A32. This one, this vertical collection of elements would again be flipped up and turned into a horizontal collection. This will be written as this A13, A23, and A33. If you notice properly, you will find out that here the elements of the main diagonal they remain the same. This one is still the same here. This one is still the same here. This one is still the same here. So what does this conclude? That the transpose, like if a matrix is square matrix, then the transpose matrix of that would have the same diagonal as the original matrix. This concludes that. Note that down. Okay. So after that, we are gonna be learning about what? We're gonna be learning about certain operations of matrix. I only thought that I would only teach you guys what the classifications of matrices were, but let me actually teach about a few basic matrix operations as well, like addition or subtraction or multiplication. Division doesn't happen in matrix. Okay, so instead of classifications, now let's write down here operations. Okay, addition or subtraction. Okay. Now we have a let's say a matrix here called two matrices here. 1, 2, 3, 4. Another we have here named B, A and B with 5, 6, 7, 8. Okay. Now, when we'll be asked to add or subtract these two matrices, what we would do is we would add or subtract the corresponding elements of both matrices, and the resultant matrix would be the result of those operations. So basically, what I'm saying is A plus minus B would be 1 plus minus 5, the corresponding element of matrix A, like this element 1, the corresponding element of this in matrix B would be 5. Okay, 1 plus minus 5, 2 plus minus the corresponding element of 2 in this one, that is 6, 3 plus minus is 8, 7, and 4 plus minus 8. Got that? Now